Okay, this is orange IRR key, okay? Because I showed you how to calculate the internal rate of return, or actually yield to maturity, the same thing, right? Yield to maturity is the same thing as the internal rate of return, because what we were doing. So in typical bond calculation, bond value calculation, it was I divided by 1 plus KDT plus M divided by, well, this is summation of, yeah, we have summation there, or 1 plus KDN, right? So we're talking about initial investment of P0, right? If you purchase the bond at P$0, and every period, typically every 6 months, you receive the interest payment, okay? And then at the end, in addition to the interest payment, you have one lump sum payment of the par value, okay? So the total value of the bond is you have to add all the discounted cash flows, okay? So typically, if you're trying to find the current value or present value of any particular bond, okay, you could provide the discount rate, say current market interest rate is 4%, right? Then you can discount all the cash flows at 4% and calculate the present value. Let's say present value comes out to be, say, $850, right? But the current market price of this bond is $900, right? Then your decision should be, well, I'm not going to buy this bond because even though price is 900, actual present value is only 850, right? That's how you use this formula, right? Or you can actually try to calculate the internal rate of return here, right? Or what we call yield to maturity, right? And in that case, we know this value, initial investment. Suppose right now you have to pay $900 to purchase this bond, right? And it pays, say, $50 every 6 months, something like that. And at the end of the term, you get, well, $1,000 back, right? Then what is the actual yield? If I purchase this bond right now and hold it until maturity, then what's the yield to me, right? Yield to that's the concept of yield to maturity, right? So in the last class, I showed you how to use the calculator. So you just provide this value as the present value, right? And this one, typically 1,000 as the future value, right? And I as the payment, and provide number of periods, okay? And solve it for the interest rate, right? And in that case, I told you just press I, right? This white I key, interest rate, right? So the question was, what is this IRR key for, orange IRR key, right? Well, that's the case if you want to calculate the internal rate of return by actually providing the cash flow, right? So instead of using payment, right, you can actually use the cash flow function, right? For example, if you paid $900, then you can say 900 change sign and provide it as the C of 0, right? C of 0. Did I do anything wrong? Is that right? Oh. I think I did something wrong, right? What did I do? Oh, I pressed the orange key. So it's saying the net present value is 0 currently, okay? All right, so let's say 900 negative and blue key and CF0, right? Okay. And let's say you get $50 every year, right? $50, and let's say CFJ, right? And suppose you have, what, 15 years remaining, right? Then let's say 15 and what? Did I press CFJ? Oh, sorry. I took some allergy medication. Okay, let's clear the memory here. All right, so let's say 900, change sign, and that should be what? CF0, right? CF0, okay. And 50 as CFJ, and 15 as number of repeating payment, okay. Did I change the sign? 900? Negative? Good. Okay. All right. Then what should I do? Okay. At this point, did I miss anything? Because we're trying to calculate the internal rate of return. See what happens here. So future value. So 15. So there should be another. Yeah. So yes, since I already entered 15, right? You have to enter the last payment. So let's say we have 16 years remaining, right? Because the last payment has to be I plus M, right? So that should be 1,050, okay? I think it should still work, right? So as long as, let's say 1,050 as the last payment, okay? Now we'll see what happens. Yeah, 5.99% as the internal rate of return, okay? So, basically there are two separate ways you can do that, right? When you do the bond calculation, obviously we have repeating payment of the same amount, right? So you can simply put it as the payment key, right? And calculate the internal rate of return by pressing I here, right? Or you can use the cash flow function, just like we did right now, okay? And then in that case, you would use this orange IRR key. Okay? All right. If you need any further explanation, let me know at the end of the class, okay? All right. All right, so once you calculate the internal rate of return, then if you are dealing with independent projects, right, then just accept all the projects whose IRR is greater than the cost of capital. In other words, as long as your internal rate of return is basically rate of return on your investment, right? So as long as rate of return exceeds the cost of capital, but it's worthwhile, right? It's worth investment, right? If you're dealing with the mutually exclusive projects, then you should accept the one with the highest IRR. If you have to choose one, right, then of course you would choose the one with the highest IRR, right? Here it says conflict may occur between NPV and IRR for mutually exclusive projects. What are we talking about? Okay. Huh? So here are two projects, A and B. These are the projects that we dealt with some time ago in our textbook. Yeah? We have this project A cash flow statement and project B cash flow, right? So using these numbers, they have constructed the relationship between the net present value and the cost of capital or discount rate. Okay? So for example, using that cash stream of project A, if you discount the whole cash stream at 5%, for example, right, then the net present value would come out to be somewhere here, let's say around 15,000, right, and so on, right. And if the discount rate comes out to be about 13%, right, then the net present value is equal to 0, right? And you know that that's the concept of IRR, right? IRR is the discount rate which makes the discount present value of or the future cash flow equal to the initial investment, right? So that the net present value will be 0, right? Okay, here again. This is the formula, right? So IRR is the discount rate which makes this term equal to this term, NINB, right? So that the net present value will be equal to 0, right? So, yeah, that's obviously if you discount the future cash flow at lower interest rate, then you're going to have large NPV and so on, right? The project B, using the actual cash flow of project B, they came up with this green curve, right? All right. So if A and B are independent, right, then you can accept both, right? As long as what? You can accept both A and B as long as okay, yeah, yes, that's the case. I mean, as long as you have enough money, right? And what?
If they're not mutually exclusive?
Right. I already stated that these two are independent projects, right? But is there any other condition? Yeah.
If the discount rate is below 13%?
Right, exactly, right? As long as discount rate is lower than the IRR, or as long as IRR exceeds the discount rate, or, well, cost of capital, okay? So for example, I mean, you can accept this project A as long as your cost of capital is less than 13%, because the internal rate of return on this project A is 13%, right? If you have to borrow the money at 14% or 15%, it doesn't make sense, right? Because cost is greater than return, right? All right, so that's the case, right? You can accept both A and B as long as cost of capital is less than 13%. If the cost of capital happens to be 15%, then what's the story? Then you should accept only B, right? Because for project B, internal rate of return is 18.2%, okay? So it makes sense to invest in that project, right? But not in project A, okay? Well, okay? But if project happened we have two projects that happen to be mutually exclusive. In other words, you have to choose one. Okay? And as an example, textbook gives you these two projects, L and M, right? And it's a very simple project. Both projects cost $1,000 as initial investment, NINB, right? And the project L has only two cash flows, 667. Project M does not earn anything in the first year, but in the second year, you can expect $1,400, okay? So if you calculate the net present value at 5% cost of capital, right, then it comes out to be $240 and $270, okay? So we're talking about at this point, if the cost of capital happens to be 5%, right? Then the project M, NPV is 270, okay? And project L, the NPV is 240. Okay? Well, if you calculate the internal rate of return for each project, it comes out to be 18.3% and 21.5%. Okay? So they came up with these curves, the red curves and green curves. Okay? So first of all, if the cost of capital happens to be above 15%, above 10%, like 15%, right? Which one should you choose? L, because you get higher net present value, right? What if you use internal rate of return criterion? Which one should you choose? Still L, because internal rate of return for L is 21.5%, but for this M, the blue dot, red dotted curve, right? It's 18.3%, right? So it doesn't matter which criterion you use, as long as cost of capital is above 10%. Well, above 10%, below 18%, below 18.3%, right? If the cost of capital happens to be 20%, what's the story? Which one? Only L, right? Because the project M, the red curve, right? Internal rate of return is only 18.3%, right? So obviously, if you have to pay 20% cost for your capital, doesn't make sense to invest in project M, right? But as long as the cost of capital is between 10 and 18%, right? You have consistent result, whether you use NPV or IRR criterion, right? But if the interest rate or cost of capital is below 10%, then you got a problem here, right? Because if you use NPV criterion, then you should choose project M. But if you want to use IRR, internal rate of return criterion, then obviously this green curve, project L, gives you higher return, 21.5%, right? You see that conflict? Okay? So what should you do in that case? Suppose your cost of capital is 5%. Which one do you trust? NPV or IRR? Why? Actual money? Yeah, NPV gives you the net present value of cash flow, right? While IRR gives the rate of return. But rate of return is still actual money too, right? Right?
If you can afford without benefit for a year.
Oh, okay. So you're talking about these cash flows, right? Right. Okay. All right. Yeah, I guess that is an acceptable argument because if you choose project M, then you don't get anything over the first year, right? You have to wait 2 years to get any cash, right? Well, in general, if you have to choose between NPV and IRR, they recommend you to choose NPV because there is a difference in the assumption, right? When you use IRR approach, The IRR approach assumes, is it here? Yeah. The IRR approach assumes that the cash flows are reinvested at the IRR, internal rate of return, right? And that may be unrealistic, right? What are we talking about? Here, look at this project L, right? First year, you get $667 return, or that's cash flow inflow, right? So you have earned the $667. What are you going to do with that money? Put it in the bank or in your pocket? Right? You have to reinvest. Put that money in a new project, right? Or something, do something with that money, right? The assumption is when they came up with the 21.5% annual return, right? The assumption is this money, 667 earned in the first year, is reinvested at this rate, assuming that all the cash flows in between, in the middle, are reinvested at the same rate, right? They came up with this annual return of 21.5%. That's how IRR is calculated, right? So, for example, what was this? Okay. Here's the project A, right? And for project A, IRR came out to be what? 13%, right? That assumes that all these cash flows in the middle, starting from the first year, 12,500, all these cash flows are reinvested at the same rate, at 13%, right? Assuming that the internal rate of return comes out to be 13%. Okay? You understand the idea, right? The net present value doesn't have that assumption because we provide this K. In order to calculate net present value, you have to provide the K, right? What's the cost of capital for this company, right? So that means all the cash flows in the middle are reinvested at the cost of capital for that company. The question is, which one is more realistic assumption, right? IRR assumes that all the intermediate cash flows are reinvested at IRR rate, right? While NPV approach assumes that all the intermediate cash flows are reinvested at the cost of capital. Well, in general, they think that the second one, net present value approach, is more realistic, right? Because internal rate of return is calculated based on specific project A, B, C, D, right? And reasonably and naturally, IRR will be different for each project. Some project may be quite profitable. Some project may not be that profitable, right? So you cannot assume that when you have the money received from project A and invest in project B or project C, you will earn the same rate of return. Well, it could be higher or lower, right? So they think that assumption is not as realistic as the assumption of net present value approach, where they assume that all the available cash flows are reinvested at the cost of capital for this company, right? The cost of capital, I mean, at what percentage interest rate the company can borrow money, right? Does it make sense? Well, it's not really foolproof approach, right? Because you can argue that, well, last year when they started project A, they were able to borrow money at 5%, right? But this year they got the cash flow from project A and they have to reinvest, right? does the market interest rate remain the same? Right? Did the market interest rate still the same? Remain the same from last year, right? If the market interest rate went up to 8%, then cost of capital is 8%, right? Because we're talking about opportunity cost, right? If you reinvest this money you receive from project A, what's the opportunity cost of that money? You know, you have to consider where else you could have used this money, right? Okay? So that's the idea. That's what we are talking about. Okay, so the conclusion here is, in case you have the conflict like that, right, then you should choose NPV approach, net present value approach. Okay. So here's the summary of that, the pros and cons for internal rate of return, right? Advantage is it considers the time value of money. Well, of course, right? Interpretation is easier than NPV. Well, I said last class that this is kind of subjective, right? Some people might think NPV is easier than IRR concept, internal rate of return, right? What do you think? Do you guys feel NPV makes more sense? I mean, easier to understand, or IRR is easier to understand? Anyway, I guess this is subjective view of the textbook authors. Okay? Disadvantage is non-normal cash flow pattern can result in multiple IRR. Yeah, here's another thing we have to understand. Yeah? The normal cash flows are something like this. Okay? Initially, you invest certain money, so there is a cash outflow initially, right? And sometimes it requires multiple investment, right? So first year you have to invest, let's say, $1 million. Next year it still requires maybe $500,000 investment, right? So here we have negative here. But then sometime after that, the cash flow turns positive, okay, and remains positive until the end, right? That's what they call normal, okay? Normal cash flow. Okay? Non-normal cash flow means, well, initially you started with the negative, it turns positive, and then for some reason it turns negative again, right? And that may be end of the story, or there may be another turn, right? Something like that, right? So if you have more than one change from negative to positive, or from positive to negative, right? Then, in other words, if you have more than one sign change, right? It's called non-normal cash flow. Non-normal cash flow. That's what they mean by non-normal cash flow, right? Then, if you actually calculate IRR with this cash flow, you got a problem. Because, you know, IRR is the rate of interest which makes net present value equal to 0, right? So if you have this kind of pattern, then we have one IRR happening right here, and the second IRR happening here. Okay? Let me give you a very simple hypothetical example. Right? Let's say CF0, CF1, CF9, CF10. Let's say CF0 is negative 3, and from 1 to 9 they are all 1. And then the CF10 is negative 6.5. Why don't you pull out your calculator and calculate IRR using the cash flow function. clear the financial function and the register, okay? I'll give you 1 minute to try. Okay? So you should enter -3 as the CF0, right? And 1 as CFJ, and then repeating for 9 times, okay? And final cash flow is -6.5, right? And then simply press orange key IRR. Oh, did you guys get my email about the textbook? Okay, someone had some used textbooks. So let me know if you still need to buy a textbook. That's you, right? Somebody, who was it? I guess he's missing today, right? What did you get? Error. You should get error, okay? Because you have more than one IRR, right? It's indeterminate, right? So, yeah, that's the problem. If you have non-normal cash flow, you may not be able to calculate IRR, okay? All right? Okay? Now, and then we also talked about this assumption that the cash flows are reinvested at IRR may be unrealistic because, not all the projects are the same, right? Some projects are profitable, some are not, right? So IRR assumes that all the money is reinvested at the same rate, right? And so that's why we prefer net present value approach, right, over IRR. Last method for evaluating project that we're going to consider is payback period. Okay? Any questions so far? So payback period is the payback period. It measures how long it takes to recover your investment, right? There are 2 different approaches, discounted payback and non-discounted payback. But non-discounted payback certainly doesn't make any sense because it completely ignores time value of money, right? So discount payback period uses the net cash inflows discounted at the firm's cost of capital to determine the number of years or number of months, right, required to recover the net investment in a project. Okay? So once you decide payback period, how do you use it? Well, if the payback period is less than or equal to specified maximum period, then you should accept it, right? In other words, for some reason you have decided that it shouldn't take more than 5 years to recover the initial investment, right? Then if the payback period is longer than 5 years, then you should reject it. Right? That's a very simple idea. Okay? So here they give some examples. The first one, column A, is undiscounted cash flow. Okay? And the story here is, initial investment is $50,000, right? And project A here, project A, if you consider undiscounted cash flow, so you got 12,500. This is the same project A that we talked about before, right? For 6 years, right? So total accumulated cash inflow is 75,000, right? So if you divide the initial investment, net investment 50,000 by the annual cash flow, you get 4 years. So it takes 4 years to recover $50,000. Okay? But as I said, it doesn't make any sense because it ignores the time value of money. Right? It's treating the $12,500 now and $12,500 5 years later equally. Right? So you shouldn't do that in finance. Okay? You cannot ignore the time value of money. Okay? So here, right. If you discount these cash flows at 14%, right, then you got these discounted cash flows, right? And so using this, how long does it take to recover 50,000? What do you think? The answer here, payback period, is undefined. Why? Why is it undefined? Right, because the project is supposed to last 6 years, but until the end of 6 years, you have not recovered 50,000. Total discounted value of the total recovery was only $48,600, right? So, what? Project A is out of question, right? All right. What about project B? Forget about undiscounted, right? How about discounted, right? When you discount the cash flows at 14%, right? These are the cumulative cash inflow. So 1 year, 2 year, 3, 4, 5, yeah. Before you reach 6 year, right? You will recover $50,000, right? So yeah, how do you come up with this 5.43 years, right? We're talking about one, two, three, four, 5, 6, okay? And at the end of 5th year, it was 44,055. Okay? But at the end of 6th year, you have recovered the 57,735. Okay? The point is, you need to recover 50,000. You need to find out how long it takes to recover 50,000, right? So, well, what they do is they calculate this distance, 50,000 minus $44,055, and divide it by the annual cash flow. The cash flow during the last year was 13,680, right? So you divide that by 13,680, and the answer is it takes about 0.43 years, right, to recover that distance, that difference, right? So it's kind of interpolation idea, right? Yeah, so that's what you have to do to come up with the exact payback period. Okay? Yeah. Again, if you decide to use payback period method, then you should use discounted payback period, right? Because undiscounted doesn't make sense. Yeah? Advantages of payback period method, it's simple, right? Okay? If all your concern is I need to recover the initial investment as quickly as possible, right? Then, of course, payback period gives you a very quick answer, right? Can you recover it within your time limit or not, right? It provides measure of liquidity, right? Because recovering the initial investment is a concern about liquidity. What is liquidity? Right. Cash or whatever the capital you can use immediately, right? I guess in economics you can say means of payment, right? Means of payment you can use available immediately, right? That's what we mean by liquidity, right? And one of the most important financial ratio is liquidity ratio, right? Because if you don't have enough liquidity, what can happen? Payments come due, you don't have enough money to pay the bills, what can happen? What? Bankruptcy, right? You may have to declare bankruptcy to protect yourself, your company, right? So that the creditors will not be able to come and take away your asset and so on, right? So I usually liken it to heart attack, right? All other financial ratios like debt-asset ratio or profitability ratio, if those ratios are not good, then you may have some time to change that, right? But if you have a bad liquidity ratio, right, it's like a heart attack, right? And you can kill your company very quickly, right? So you have to be very careful about the liquidity, right? Provides a measure of risk. Yeah. Okay. Why? Why is it a measure of risk? Yeah, sorry.
Maybe because the longer it takes to pay back, the more risk you have.
Right. That's actually that was the topic of chapter 8, right? Last semester, right? Or chapter 8 in this book, right? They talk about risk, right? And there's a time horizon, okay? The longer the project or the longer the investment, right? The risk increases because you never know what's going to happen tomorrow, right? You never know what's going to happen a year later. If you're talking about 5 years later, right? Anything can happen, right? The U.S. government may go bankrupt in 5 years, right? So right now, the U.S. government bond is considered the safest investment, right? But well, as the time horizon increases, that may not be true. I mean, you cannot trust, right? That 100%, right? Okay, what do you think about the rate hike? Actually, in a few hours, right? Fed is going to announce whether they are going to increase the interest rate, right? After about 7 years. Last 7 years, they have not raised the interest rate, right? Just kept lowering and lowering, right? But sometime tonight, Korean time, so I guess sometime Thursday morning, Sunday morning or afternoon, yeah, they're gonna announce. Right now, as far as what I heard this morning, economists split to 46 to 49%, something like that. 49% economists believe that they're going to raise the interest rate. 43% believe they're not going to raise the interest rate. What's the use of economists? Huh? Yes. The joke is if you gather 3 economists in one place to find the solution, they come up with 5 different solutions. So, lots of jokes about economists. All right. But I don't think, whatever happens, whether they increase the rate or not, I don't think there will be a significant impact on the stock market because it's already have adjusted significantly last, couple of weeks. It was crazy. Right? All right. Disadvantages. Discounted PB ignores the time value. Undiscounted payback ignores the time value of money, of course. Yeah. Ignores cash flows after the payback period. Yes, that's another huge problem, right? So, when you use a payback period method, all you are interested is, how long it takes to recover your initial investment, right? So, for example, here, initial investment is recovered between 5th year and 6th year. And what if the project continues, right? So you have one project like this, ends at 6 years. You have another project with exactly the same cash flow or even lower cash flow, but it lasts 10 years, right? So this project, it takes 5.43 years, but the other project, which lasts 10 years, right? It takes, let's say, 6 years to recover the 50,000. Then are you going to choose this project because it takes shorter, 5.43 years to recover 50,000, and ignore all the rest, then 7, 8, 9, 10th years cash flow? Doesn't make sense, right? Because your goal, ultimate goal, is to increase or maximize shareholders' wealth, right? And if you're really pressed by money or liquidity, right, you really have to pay back 50,000, right, within 6 years, right? Then maybe you can choose this project. But otherwise, it doesn't make sense, right, to ignore the future cash flows. Okay? So that's what this last point is about. No objective decision criterion that maximizes shareholder wealth, right? Again, if the company is really squeezed with money, right, and they really need to recover the initial investment very quickly, then you can consider payback method, right? But otherwise, it's not really desirable. Okay? All right, why don't you look at this summary, see if you have any question. The next topic is about capital rationing. So when a company faces a capital constraint, right, then how should they come up with the decision, right? The general rule is you have to rank order, or you have to sort the projects in terms of their profitability index. Okay? And of course, if the profitability index is less than 1, then that should be out of question immediately, right? Because you're not even recovering your investment, right? But then you have to, in general, you have to choose from the top, right, until you exhaust your fund, right? So, like this, we have 8 different projects listed here, okay? And here's the net investment for each project, net present value, and present value of net cash inflows. So you calculate the profitability index. Okay. So apparently these projects are sorted based on profitability index. Okay. And of course the last one, W, is out of question because its net present value is negative, which means profitability index is less than 1, right? So that's, thrown out immediately, should be. Okay? All right, and then think about the cumulative net investments, so add them up, all the net investments required. And the story is, this company has a $550,000 capital budget, right? So you can afford up to $550,000 total cost, total investment, right? And here that separates, that line comes here, right, between 525 and 575, right? So normally you would accept PRSU, right, projects PRSU, and well, then you have what, $25,000 remaining, right? And what can you do with that $25,000? Go out and have a party? Yeah. Put it in the bank? Reinvest? Right. Okay. Yeah. So the question is there any better alternative? Okay. So because right now the idea is you need to maximize the return, right? And apparently these projects return what, 25%, 22%, 21%, right, on your money, right? But I don't think you can find 20% return at a bank, or just buying a bond or something like that, right? It's probably impossible to make 20% return, right? So is there any better alternative? Well, that's the question here, right? So what happens when the next acceptable project is too large? Well, of course, it'll probably happen in reality, right? Just like in this example, right? Oops. We have some money available remaining, 25,000, right? But apparently that's not enough to afford the next profitable investment, right? So what should you do? You have to search for another combination of projects that will increase the cumulative net present value. So what we're talking about here is, instead of PRSU, is there any other combination that comes within the budget and increase the net present value? I mean, total net present value, right? And they say apparently, here. PRSTV. So if you drop U, then you save $100,000, right? But instead you add T and V. T and V together cost what? $125,000, right? So if you add them up, PRSTV, you're going to have exactly $550,000 investment, right? And of course, these are, I mean, this is our hypothetical example, right? To make the point that they made the numbers so that it will work out perfectly, right? So instead of PRSU, if you give up U and PRSTV, then you can afford 5 projects with the $550,000 investment. Question is it better, right? So you have to look at the cumulative net present value, right? So if you add, if you have 4 projects here, the total net present, cumulative net present is 114,750, right? But if you forget about this, 525 coming from U, and instead you undertake T and V, well, obviously, that's the investment, sorry. Where's the present value? Net present value, right. Okay, here. So you give up 20,000 coming from U, but if you take T and V, it's gonna be what? 21,500. Okay? So obviously that's gonna increase the total net present value. Okay? So that's the first suggestion. See if there is another combination of projects, right, that can be made within the budget, but increases the total net present value. Okay? If you cannot find that combination, then you attempt to increase the capital budget. Of course, it's an obvious thing, right? If you can't do that, if you neither is acceptable or feasible, then the excess funds in short-term securities. Why short-term securities? Less risk, right? And who knows, tomorrow you may come up with a new idea, right? Or new project, profitable project, right? And so you don't want to lock up your money in the long-term investment. Okay? Even though long-term investment usually pays higher interest than short-term investment, right? Okay? All right, that's the idea. So when everything's done, when you evaluated the alternatives, well, first of all, you have to come up with the alternative proposals, right? You have to find all available opportunities, right? And then you calculate the net cash flows expected from each project, right? That was chapter 9, right? And in chapter 10, we talked about how to compare, right? We talked about 4 different approaches to compare and assess the projects, right? And make the decision. So then, of course, you're going to implement the projects, okay? And when the projects are all done, then you have to review. Or sometimes you review in the middle of the project, right? So reviewing and post-auditing an accepted project. Of course, you have to compare the actual cash flows to projected cash flows. See if you can find the systematic bias or error, or systematic error, right? Why not unsystematic bias? Do you need to worry about unsystematic bias or error? Yeah.
It's not like you can account for something unsystematic in the future anyway.
That's right. So that's the reason why they say systematic here, right? So, you know, if this problem, bias or error, or any problem you encountered was unique to a project, right? Then it's not going to help you next time, right? Because it's highly unlikely that you will repeat the exactly same project, right? And make exactly same mistake, right? But if you can uncover some systematic bias, there was some problem in the way you evaluated the project, right? Somehow the guy who calculated the IRR made a big mistake. He had no idea what he was doing, right? Then you need to know, right? So that you're not going to repeat the same mistake, right? Decide whether to abandon or continue projects that have done poorly, right? So we're talking about in the middle of the project, right? You have to constantly review how it's going, right? And if it's really different from what you have expected, then you may have to abandon the project, right? That's what we call real option, right? Real option. All right, I think I'm going to stop here today, and we're going to finish this chapter on Tuesday. Yeah. Any question?